the transit of Mercury, the orbit of 51 Eridani b. Let's enjoy the wonders of these two very different planets.
Science violation. News flash.
Welcome to another Science Violation News Flash with your host, Professor Jenkins. And on today's show I want to share with you two astonishing videos from two very different planets. The first from the well-known and much-loved planet in the solar system, Mercury. And the second from the less well-known but certainly much-loved in the scientific community planet, 51 Eridani b. Okay, let's start with Mercury. Beginning at around 1200 hours UTC yesterday, November 11th, 2019, Mercury passed across the disk of the Sun given our line of sight, and it provided earthbound observers with a wondrous transit to observe. Now, Mercury is about 40% the size of the Earth, which makes it around 285 times smaller than the Sun, so the transit that you can see is just a small speck almost passing in front of the solar disk. Now, not only is Mercury the smallest planet in the solar system, but it's also the closest to the Sun. 1 year on Mercury lasts around 88 days. That means it takes about 88 days to orbit the Sun once. And it also makes it a challenging observation for observers here on Earth. The planet's best observed late at night, just before sundown at dusk, or early in the morning, just before sunup in morning twilight. Of course, from space we have none of those problems. Here we can see the transit of Mercury. We can see Mercury pass in front of the Sun from NASA satellites in different wave bands, and we can see just how small Mercury is compared to the large disk of the Sun, for instance. We can also see in detail many features on the surface of the Sun. These come from active regions, magnetic fields rising and bursting through the surface of the Sun. Ironically, these active regions on other stars cause observers on Earth many problems to detect planets orbiting other stars. Although it's fantastic to observe these astronomical events using space-based telescopes, we can witness the transit of the Sun by Mercury in real extreme detail, and I encourage you to go ahead and search for more such images. It's a more personal experience, in my opinion, more fundamental to our understanding if we can witness them from here on Earth. And so now I want to show you some images that we took on Cerro Calan in the office. Here we can see some projection images using our 28cm refractor on Cerro Calan. This is a Cardossiel type astrograph that was installed in Quinta Normal in 1894 and built by Gautier. It was then moved to Lo Espejo and later Cerro Calan, where now we use it mainly for outreach. And here we can get a glimpse of what's possible from the Earth. We also can see the size and projected scale when compared to a 10 peso coin that I put next to the image of Mercury. Wonderful stuff. Okay, from observing an object only 93 million miles from us, the Sun, I want to take you on a voyage to another star system, 51 Eridani, which is located at a distance of 564 trillion miles from us. That's 564 million miles from planet Earth. In that star system, we find a giant planet orbiting the star, a massive planet that we can directly image due to the young nature of the object, and that allows us to witness the orbit of this planet in real time. 51 Eridani, the star itself, is slightly more massive, slightly larger than the Sun. It's classed as an early F star, and it's also part of a moving group. Now, moving groups are special collections of stars. They're young collections of stars that were formed in the same gas cloud and haven't yet had the time to spread out into the galaxy. And this means that we can give a precise age to the star. And we know then, given that it's part of this moving group, that the age of 51 Eridani should be in the ballpark of 24 to 25 million years old. Now, back in 2006, the astronomer Erik Figelson and collaborators found that it's actually part of a binary system. It's not a single star moving through space alone. It's being orbited by another pair of stars. Actually, all three are orbiting their common centre of mass, and that makes this a hierarchical triple system. Those pair of stars are named GJ3305A and B, and they are on a very widely separated orbit. The orbital period takes around 60,000 years in this case, and therefore we can expect that they are widely separated enough such that no interplanetary system orbiting 51 Eridani would be disrupted as this pair of stars pass close to the planetary system on their elliptical orbit. So considering this wide orbit, considering the fact that 51 Eridani is young, and young planets are significantly more luminous than older planets due to the fact that they are still radiating away all this gravitational energy from their formation, we turned our cameras towards 51 Eridani and actually, incredibly, found a giant planet orbiting the star. And so in 2015, Bruce McIntosh and collaborators published a paper showing the discovery of a giant planet orbiting 51 Eridani. The planet was discovered using the Gemini Planet Imager, which is an imaging camera mounted on the Gemini telescope in northern Chile, and it has the capability to deal with the distorting effect of the Earth's atmosphere on the images. Analysis of the images revealed that the planet should have a mass anywhere between 1 to 12 Jupiter masses, depending on which model we select for the formation of the planet. Now, if we can map the planet's orbit, we can apply something called astrometry to kind of break the degeneracy between the models and get a better idea of what the mass of the planet should be. So a team of astronomers have set out to do just that, to try to map the orbit in real time of 51 Eridani b. And a paper was recently published by Robert De Rosa to show 4 years of data from the Gemini Planet Imager, and from that 4 years of data we can constrain the orbital characteristics of the planet. And that's what I'm going to show you now. So feast your eyes on this incredible image. Now, what we can see in this series of images is that the planet 51 Eridani b is the bright point of light that was making this curved motion, and that's it orbiting the star, and the star 51 Eridani is in the centre of the image behind this blacked out circle, and that blacked out circle represents what we call the coronagraph. Now, a coronagraph is what astronomers use to block out the light of the star, allowing us to observe very faint objects that are very closely separated to the star on the sky. It's kind of like when you put your thumb in front of the full moon in order to block out the moon's glare, and that allows you to see faint background stars very close to the moon. Now, this additional light that we can see just around the blacked out circle, that's the residual glare from the star, something we astronomers call speckles, or the speckle pattern. And that's just an instrumental effect. And the more we can remove that stray light, that speckle pattern, the fainter objects we can observe even closer to the star. Now, we also have a scale here, the white line with the 10 AU above. And that AU is an astronomical unit. And an astronomical unit is the average Earth-Sun separation. And so that means that 51 Eridani b is orbiting at around 12 astronomical units, or 12 times the Earth-Sun distance. And finally, the set of images here were actually 5 individual images that have been interpolated, and they were taken across a period of around 4 years with the Gemini Planet Imager. And that allowed the astronomers to build up this absolutely spectacular set of images. So that's all we have time for today, and I hope you enjoyed this eye on 2 planets. And remember, you only need to ask the right question to change the course of history. Good night.
Science violation.